today's lesson, we're going to be looking at application questions for the normal curve, but we're going to be working this process backwards. So typically, we are given a data value and asked to find the probability of it occurring. In these types of problems today, we're going to be given the probability and we're asked to find the data value that corresponds to that probability. Here's the first example that we're going to take a look at together. It says to qualify for the police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. Okay, so let's first take a look at what this distribution would look like drawn out. So we have a normal curve that is centered at 200 and has a standard deviation of 20. It tells us that we have to score in the top 10% in order to qualify for the police academy. So I want to think about where those scores would fall on this normal curve. To be in the top 10%, I would have to fall in that right tail region. This corresponds to a probability of 0.1 or 10%. So what we're going to have to do is we're going to have to figure out, well, what z-value corresponds to a right tail region of 10%? And then we have to figure out, well, what test on the score on the test would correspond to that particular line, or what data value corresponds to that particular z-value. Okay, so first of all, let's take a look at the positive z-chart. The positive z-chart, if we scroll all the way to the bottom, does not read top 10% of data values. It does not give me the top, it gives me the area to the left. So if this tail region is 10%, hopefully it would make sense that this region would be 90%. Thinking about the area under the curve has to correspond to 100% of the data values. If this tail region, the right tail region, is 10%, that means the area to the left of that would be 90%. So I am going to scan in the middle where the probabilities are for the closest number I can possibly get in the middle here to 0.9, 90%. I always start in the first column and I go down until I'm getting close to 0.9. Here it's between these two rows, 0.8849, 0.9032. I'm going to start here. If I move to the right, keep moving until I get to the closest possible value of 0.9. Okay, I see between these two values is where 0.9 falls, but it's closer to 0.8997. This one is further above it. So I'm going to use this 0.8997 as the closest I can get to a probability of 0.9. Follow that over and up to find the z-score. So I'm seeing 1.28. Okay, so that line corresponds to a z-value of 1.28. Now I have to transform it into a data value. I'm going to use the z-score formula here. So z equals x minus mu over sigma. Filling in what we know, the z-value is 1.28. We do not know the data value, so x, I'm going to leave x. We know the mean is 200, and we know the standard deviation is 20. We're going to solve that equation for x. So we're going to multiply both sides by 20. And then we're going to add 200 to both sides. And that's going to get me x by itself. So let's go ahead and do that. So 1.28 times by the standard deviation of 20, and then adding the 200 X value of 225.6. So in order to qualify for the police academy, I would need to score 225.6 points or more. Okay, we're going to go ahead and take a look at another example together. Example 2 states, for a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and a standard deviation of 8, find the upper and lower readings that would qualify people to participate in the study. All right, so here's our normal distribution of blood pressures, centered at 120 with a standard deviation of 8. We're looking for the middle 60%, so that means that area would have to be 60%. So I would actually have the choice of looking for a z-value on the negative chart or looking for the z-value on the positive chart. When I have the choice, I have 2 here, I prefer the negative chart, but it reads left shaded regions. So this 60% in the middle really isn't helping me. But I can use it to find the area that would be to the left of this line. So let's split up that 60. 60% in the middle would be 30% on the left and 30% on the right. If I think what that would leave for this tail region, if 60% is in the middle, that leaves 40% for both tails. So that means 20% or 0.2 is the area that's associated with this left tail region. So I'm going to look at the negative chart, the closest number to 0.2. Again, I'm scanning for 0.2 in the middle here where the probabilities are. I'm going to start in this first column and scroll down until I get close to 0.2. And now I'm going to move across so I can get the closest possible to 0.2, which it looks like is this 0.2005. Let's follow that out to find the z-value, negative 0.84. So negative 0.84 is the z-value associated with that line. Now guys, if I wanted to use the positive z-chart to find this line, and the positive z-chart reads left shaded regions. So I would need all 3 of these regions added together. So the 20% plus the 30% plus the 30% gives me 80%. I would need to look up the closest number to 0.8 on the positive z-chart. But this graph is symmetrical. So if this z-value line is negative 0.84, this z-value line should be positive 0.84. Let's just check on that positive z-chart and make sure that that's true. Looking for the closest area to 0.8 in the middle. I'm going to scan this first column, 0.8, and then go across. 0.8. Go across. There it is. 0.7995 is the closest area to 0.8. And if we follow it out, that is a z-score of positive 0.84. Okay, so let's transform those z-values into x values using the formula. So we have positive or negative 0.84 equals x minus the mean of 120 and dividing by the standard deviation of 8. Solving that for x, we're going to take positive or negative 0.84 and multiply it by 8. We would get positive or negative 6.72. And then we'd have to add the 120 to both sides. Okay, so we're going to get two answers here. We have negative 6.72 plus 120. And we have positive 6.72 plus 120. This is going to give me that range of values that represent the middle 60%. So 113.28 to 126.72 is the middle 60% of blood pressures. Okay, we're going to take a look at one more example together. Example 3 says, in order to help students improve their reading, a school district decides to implement a reading program. It is to be administered to the bottom 5% of the students in the district based on the scores on a reading achievement exam. If the average score for students in the district is 122.6, find the cutoff score that will make a student eligible for the program. The standard deviation is 18, and assume the variable is normally distributed. All right, so here's our distribution of reading scores, centered at 122.6. The standard deviation is 18. And in order to qualify for this reading program, the student needs to score in the bottom 5%. So 0.05. That would be a negative Z score. And so we're going to look on the negative Z chart. Remember, both charts read left shaded regions. So we're going to be looking for that closest value to 0.05 in the middle of the negative distribution. So again, we're looking for the number closest to 0.05. And it looks like, we're evenly split. 0.0505 and 0.0495. Those are both evenly split around 0.05. So when that happens, guys, different books say to do different things. My personal preference is I want you to average those two Z values together. So if we follow it out, I see a negative 1.64 and then a negative 1.65. We are going to average those two Z's together. So if I add them up and divide by 2, I get negative 1.645 as the Z value. Again, I averaged negative 1.64 and negative 1.65 together. We only do that if they are evenly split. If they're not evenly split, we're going to go to the closest Z value. All right, let's convert that to an X. So we have the data value X minus the mean, we know 122.6, and divided by the standard deviation of 18. Solving that for X, I'm going to multiply negative 1.645 times 18, and then go ahead and add the 122.6 to it. So solving for X, we get a score of 92.99. So in order to qualify for this reading program, the students would have had to score a 92.99 or less on that particular exam. Okay, here is the U-Try. So take a moment, read through this scenario, pause the video, see if you can find the data value that corresponds to 30%, an area of 30% to the left, and unpause the video to get the results. Okay, for this UTRI example, it is a normal distribution centered at 4.8. We want to find the z-score and the data value that corresponds to the bottom 30%. Looking that up on the negative z-chart in the middle, that corresponds to a z-value of negative 0.52. Converting that to an x value, we multiply both sides by 1.45 and add the 4.8, and we get 4.046. So 4.046 days or less. Okay, this concludes the Z application backwards notes.